All right, so we'll do a few problems together off on the side today of review, because so far we've learned about how to make polar points. Let's say I give you a nice simple one here. Let's say this is at 7 comma pi over 6. Does where I put it make sense for that? Okay, then give me another name for this, one that has a positive r but a negative theta, and give me one that's got a negative r and a negative theta. So make me two more polar points. Not different points, just different names for this point. Then last but not least, figure out what it is in rectangular. You'll draw the triangle around it like this and figure out what the rectangular for it would be. And I'll show you how to do this in just a second if this is something that is stumping you. I'll pause for a minute while you give it a shot. Okay, you'll get a chance to see how this works. So if I was going to use a positive r, then I really don't have much choice. It has to be 7. And then a negative angle for this is like you go all the way around this way. And so that would be a whole bunch of pi over 6s in the negative direction. So negative 11 pi over 6. Does that sound right? Raise your hand if you had that. Okay, good. So negative 11 pi over 6. And then polar but negative means I got to go find the shadow point. Over there, there's another dot. And I got to figure out its name. Its name is 7, comma. You might think its name was negative 7. It's not. Its name is 7, comma. These are pi over 6s, so 7 pi over 6. But I needed a negative angle also. Okay, so then that going this way, it would be negative 5 pi over 6. And some people, again, think this is a negative point over here. It is not. When I reflect it over here, it'll become negative 7 and negative 5 pi over 6. Okay, and then last but not least is the rectangular. If this is 7, but the classic right triangle with the 30, 60, 90 is 1, 2, and root 3, then I'd like to set up a deal where I go x is to 1, which is just x, like 7 is to 2. So x is 7 over 2. And I shouldn't have called that x. I should have called that y. Sorry. So the y value of my point would be 7 over 2, also known as 3.5. And the other side here I should call x. And x is to root 3, like 7 is to 2. So then that's 7 root 3 over 2. Seven root 3 over 2. Okay, that was not an easy one, but there it is. That covers polar, rectangular, and negative r values. Is there any part of that you'd like me to explain? Just to make sure I didn't mess this up, let's have you chip in. Did anybody else get 7 root 3 over 2? Oh, a lot of people did. Okay, good. All right. And this one just has to be half as big as this one, right? So that makes sense. It'd be 7 over 2 or 3.5. Okay. Then, what else have we learned? Converting. If I just say r equals 5, it's pretty easy. That's a circle with a radius of 5. Now, you might have already learned how to do this in higher algebra, and you can just go, I know how to make a circle with a radius of 5. It's like that. But unless you have that already in your head, I gave you 4 things that you should memorize. And then I said, you know, instead of memorizing it, maybe you could just remember what this drawing looks like. And here's the drawing. X, Y, and R, and theta. Would you please recreate the 4 things that convert polar into rectangular? Like, for example, cosine of theta equals something, and then if you solve it right, that'll convert polar to rectangular. There's 4 things I told you to memorize. See if you can recreate them right now. All right, I'd like to take a volunteer. Anybody know one of these? What do you got, Sasha?
X equals R cosine theta.
All right, so that one came from cosine is x over r, and then you just multiplied both sides by r, and you came up with x equals r cosine theta. And that probably makes you go, oh yeah, the other one's y equals r sine theta. I hope it just makes you do that. Otherwise, you'd have to instead write sine of theta equals y over r, and then solve it like this, and then that's how you get y is r sine theta. Next is x squared plus y squared equals r squared. That is a Pythagorean. You just, this is a right triangle, so that must be true. X squared plus y squared equals r squared. And last but not least is tangent. Hopefully you remember it's y over x because it's sine over cosine. Who had all 4 of those right? Awesome. Then how are you supposed to convert r equals 5 here into rectangular? Well, there's 2 types of questions I want you to consider. This kind and this kind. I'm going to make the other one blue here. On the black one, I would do something to it first, and then I'd be able to convert it over. On the blue one, I would do something different to both sides, and then I'd be able to convert it over. Can anybody name something we could do to one of these 2 to be able to convert it over? Jody.
On the black one, you use square r.
You are correct. You square both sides. And just stop for a second and let's talk about why that helps. I know you know. Anybody else tell me why is that good? Like, why do you want to even square it? Neil? Yeah, because then you got this one. X squared plus y squared equals r squared. And I see the r squared right here. That now can be replaced with x squared plus y squared. So now I got x squared plus y squared is equal to 5 squared, which is 25, and that's rectangular. So they started off as polar, and we're changing them over to rectangular. Now on this one, you might think, well, yeah, I'll square it again, because there's an r, and I get why you'd think that, but there's no cosine squared in the list over there. So there's a much smarter way to do it. Don't square it. Anybody have any suggestions if we're not going to square it? Sophia?
You multiply R.
Times by r. Now look at how quick that changed to r squared, which is x squared plus y squared. And then r cosine theta is right on my list. R cosine theta is x. There, it's changed to rectangular. Now, was there another way to do that? There was, but it was a lot harder. That was fast. So keep those little tricks in your mind. You can square both sides, or you can times by r. Sometimes the one way works, sometimes the other way works. All right. So now, I think we've covered enough that, remember, this is the signed that you would do these next couple pages, like this page. I mean, yeah, I hope you can plot -2 comma 4. It's as easy as you'd think. Then they want you to plot the polar point, which those are, a little trickier, especially when they start with a negative. Because then I've trained you to don't do the negative. Figure out where 2 comma pi over 4 is, and then it's like 2 comma pi over 4, which you can all find, but then you got to do something. All right, and then this one is kind of like an open-ended, you can pick any one kind of thing. And then there's a few more problems, and then you can look at the answer key and then just turn this as a homework assignment. Okay, this should be pretty easy. But I'm going to stop for a minute here because in class, your next big goal is you and a partner are going to work through a Schoology quiz. So if you go look right now in today's folder, April 14 folder, you will see a Schoology quiz in there. I'm going to give you a partner. I'm going to ask you to actually slide over next to him and actually give this a shot together as a partner quiz. At the end, of course, you'll get whatever score you get, but I want you to work together on it. Okay? And after you're done with that, you can come back to this, and I think some of you that work really hard at this might actually be able to finish both. But maybe not. I really wanted you to have something you could do over the weekend. You know how you got a 4-day weekend here? Monday there's a Schoology quiz. I'm going to want you to do that on Monday because it's supposed to be a day where you do school but at home. Okay, so I'm giving you this short Schoology quiz. Haven't released it yet. I will on Monday. Okay, but other than that, you have a 4-day weekend, and I'm not going to see you again until Tuesday, and Tuesday will be weird. In fact, some of you won't even be in here. What? Well, some of you are going to be juniors taking the ACT, or not the ACT, the MCA, and some of you are going to get, other people are going to come from other rooms and be in here. So Tuesday and Wednesday are going to be really weird. All right, so that's all I have for the video for today.